Howdy, y'all. It's Mr. Bowsy. I hope you're having a fine quarantine. I'm going to go over part 4 of the project for any of you that are struggling with it at home. I did a quick little example. I think the day must have been Friday, the half day. Maybe it was Thursday. Doesn't matter. On how to do part 4, I'm going to show you again. All right. We're going to use information using Venus, which is pretty close to the size of Earth. So it's a good example of how this works. So part 4, here we go. All right, so here's my data. All right, Venus, this is all the info I provided. Now on part 4 of the project, you guys have to figure out using the interwebs what the thickness of the different layers are. All right, what's the inner core, what's the outer core, the mantle, the crust. Once you determine that, I tell you that Earth's radius is about 6,371 kilometers. All right. Here, I provided all the info for Venus for you. All right. And we're going to go through this real fast. So the first thing we got to do is figure out our scale. All right. In my example, I said, let's make a 10 centimeter line. All right. 10 centimeters is going to represent the radius from the center of Venus all the way to the crust of Venus right here. That's what this 10 centimeters represents. Well, because we made a scale, right, I could say that 6,050 kilometers, which is the true size of Venus, I can make that, I could set that equal to my scale. I could say, okay, 6,050 kilometers equal to 10 centimeters, right? Because this is a scale model. And if I wanted to solve for 1 centimeter, all I would have to do is divide both sides by 10. And what I end up getting is 1 centimeter equals 605 kilometers. Okay, that's my scale. So every time I move 1 centimeter, it's 605 kilometers. Easy peasy. Now, on part 4 of the project, when you're doing this on the poster, you're not going to want to choose 10 because 10 is too small. As you're going to see when we get to the crust, it's really, really, really hard to draw a crust that is so thin like this on a really small scale like this. So you're better off choosing something between 20 and 40 centimeters. And the closer to 40, the better. Although there's other challenges with the backside of the poster, but still, you can still do it. Okay, so now what I got to figure out is what my scale sizes are for all of these. It's easy. I got my scale factor right here. All I have to do is set it up like a factor label problem, like you might have used in chemistry before. If not, no big deal. All right, but here's the short and sweet. I have 3,000 kilometers here. I know 1 centimeter equals 605 kilometers. Since these are equal to each other, I can quite literally set it up as a fraction and say 1 centimeter equals 605 kilometers, right? That's just like saying 20 over 20 or 10 squared over 100. They're equal to each other, right? So because they're equal, I can set it up like this. That being said, I can then cancel my kilometers. And so what I have now is 3,000 divided by 605. What you end up getting is 4.96 centimeters. Okay? 4.96 centimeters. So the mantle, notice here I say it's the mantle thickness. The core is a radius, the mantle is a thickness, and the crust is a thickness. Well, since it's the same number as this, I know the mantle is going to be 4.96 centimeters thick as well. It's this crust here that's going to be the issue. All right, setting up my factor label here. 1 centimeter equals 605 kilometers. Cancel, cancel. So basically it's 50 divided by 605. And what I get is 0.08 centimeters. Just did that math in my head. Just kidding. I totally did it on a calculator earlier, but whatever. I was trying to impress you. Did it work? I hope it worked. Anyways, 0.08 centimeters. That's a really small measurement. Remember, there's 10 millimeters in a centimeter. So this is also equal to 0.8 millimeters. All right. So basically, we're talking about less than a millimeter. Okay. That's going to be challenging for us. So we're going to give it a shot, though. Okay. So let's get to our beautiful radius down here. So on the back of your poster, you're probably going to put the interior or the core here, right? The center of Earth right on the edge of the bottom left of your poster. All right, but that's up to you. Maybe the bottom right. I don't really care. All right. But you decide that's the center. This is the crust. We know this. This is the outside of it right here. Okay. What we have to do is kind of fill in the gaps of where all the other layers are. All right. So next thing I'm going to do, I'm going to make a 10 centimeter line going perpendicular to this measurement here so that, oops, oh, I'm going up into my info. Oh, well. First mistake I've ever made. All right, look at that. Oh, boy. Oh, well. Can you guys forgive me? I don't really care. No big deal. No big deal. All right, so now we have our little pie piece of the Earth here. All right, what we're going to do now is put in the different layers. So the inner core is 4.96 centimeters. All right, 4.96 centimeters. That's a really, really precise measurement. Basically, what that means is, right, we're literally going to go 4 all the way to the 9 and go slightly more than halfway between the 0.9 and the 5, right? That is super precise because remember 4.96, we got to get to that 6 there as precisely as we can. All right, so here I go. I'm going to do that right there. Okay, there's 4.96. Looks awfully close to the 5, right? But it's not. Now what I'm going to do is I'm going to repeat that measurement over and over and over again so that I can make an arc that's pretty close to being accurate. All right, 4.96. I'm going to do that again right there. I'm going to do it again right here. All right, and then I'm going to do it again way over here. Okay, 4.96. Now, go back and look. We got a series of dots. All right, not sure if you can see those dots so hot. Let's see. That doesn't help in the slightest, doesn't it? Let's give this a shot here. All right, well, whatever. There are the dots. So we're going to now just take our pencil here. Now, I'm going pretty fast, but you get the idea. The hope is to try to make a nice arc that all kind of blends together like that. Okay? There you go. This is the core of Venus. Woo, that was exciting. I'm excited. I don't know about you guys, but that was pretty exciting. So the next thing we're going to do is the thickness of the mantle. Notice it's the thickness now because we're adding on the mantle to the core, right? If I were to measure out 4.96 centimeters from the center of Venus, I would get right to where the core is, right? Obviously, that can't be the case. The mantle goes beyond the core. So I got to add another 4.96 centimeters here. So I'm going to do this right here. Okay. Take my measurement. It's about right there. Wow. So basically what we're looking at here is the crust of Venus is uber thin. Shocking. It's like 0.8 millimeters. I guess we could have predicted that. But anyways, now we're going to do the same process again, except I'm going to make my life a little easier. All right, I am going to figure out what the total length of the line is, 4.96 plus 4.96, right? Lo and behold, it's almost 10 centimeters, but not quite, all right? And I am going to mark off on here basically how far I need to go, and I'm going to do this process again. Beep, bop, blurp. That's me making precise measurements. It's the sound of a precise measurement. You've probably never heard it before because you've never made precise measurements to this degree. But you just witnessed it, so I hope you're sitting down. Makes things a little easier. All right, boom. Got all my dots. I'm not sure if you can see all the dots again, but we got a dot here. We got a dot there. Got a dot there. Somewhere up in here, and then in there. So we're gonna. Oh, there's the dot. I found that 5. All right, and then we're gonna just try to make a nice little arc here. All right. Oh my gosh. Are you kidding me? Mantle? Wow. Unbelievable. All right, so now the crust. This is why having a bigger scale, bigger than 10 centimeters, is going to come in handy. The crust on Earth is super thin, just like the crust on Venus is super thin. In order to accurately represent the crust, you're going to want to get, a colored pencil that's pretty sharp. All right. And you're going to say, okay, it's 0.8 millimeters. Really? It's less than a millimeter thick. So basically the thickness of this line that I'm drawing right here represents the thickness of the crust. All right, so that's uber thin, as we mentioned. All right, it is 0.8 millimeters. Okay, last thing you should do when you make these drawings, tell me how thick they are. Put it right here on it. Core is 3,000 kilometers. All right, scale 4.96 centimeters. All right, do the same thing for the mantle. Do the same thing for the crust. And you're done. That's part 4. Well, you got to add the atmosphere too. Don't forget true thickness of the atmosphere, what as defined by your earth science teacher. That's this guy. About 20 miles, so about 30 some kilometers. Okay, that's what you're putting in there. The true thickness of the atmosphere is also uber thin, which is kind of the point of part 4. Alrighty, folks, it's been fun. Good luck with part 4, and I hope to see you real soon. Let's see what I got to do here. Oh God, there's my face. You guys, I hope you haven't had to see that the whole time. All right, let's take a look. See here. I'm gonna stop recording. Good day to you, folks, and I'll be back here pretty soon. We're gonna do the greenhouse effect. Still.